This video is sponsored by Mel Science. Science topics often pull us in, but our limit on what we know can make us lose interest. Science is about exploration, discovery, and asking questions. There's an element of childlike wonder in all of us that makes us ask, why? Sometimes the best way to know why is to find out with an experiment. This brings me to the sponsor of today's video, Mel Science. Mel Science creates monthly science boxes for children and teens which involve hands-on experiments, combined with VR and AR technologies. They have a variety of subjects in chemistry, biology, medicine, math, coding, and more. Mel Science's goal is to make science more accessible and shed the stereotype that science is boring, hard, or just for nerds. Mel Science goes the extra mile with their science kits. I was surprised to see that they had a pharmacy kit that came with high-quality labware that you wouldn't find in most kits. I was able to make my own fizzy tablets and do a compound identification test. In a separate chemistry kit, I made crystals from iodine vapors, which was pretty cool. You can use their app to follow along with each experiment. The directions are straightforward and easy to use. I had a lot of fun doing these experiments, and I think the kids in your life, or the kid in you, will enjoy them too. You can get 50% off the first month by clicking the link in the description. Check out Mel Science today. Most people don't think about carbon monoxide poisoning on a daily basis. The most common dangerous topics among the talking heads are murder, terrorism, drugs, poverty, and disease. Relative to the threats on your mortality, carbon monoxide poisoning is very low, with about 430 fatalities per year in the US. Yet, if you look to Hollywood, carbon monoxide poisoning is often represented in film. Despite its wide use in media, it's hardly understood. In this video, I'll be covering the dark science of carbon monoxide poisoning. The carbon monoxide molecule consists of a carbon atom triple bonded to an oxygen atom. Carbon monoxide is not to be confused with carbon dioxide, the gaseous molecule you exhale as a result of metabolism. Carbon dioxide is made of a carbon atom double bonded to two oxygen. Both molecules share similar properties. They're both gaseous at room temperature, have no color, no taste, and no smell. One major difference, though, is that carbon dioxide is not toxic, and carbon monoxide is. Carbon monoxide is toxic when it's inhaled due to its effect on the function of hemoglobin. Hemoglobin is a vital protein embedded in your red blood cells, and is responsible for carrying and releasing oxygen in your blood. On hemoglobin, there are 4 protein segments called heme groups, with an iron atom in the center. When red blood cells pass through the circulation in your lungs, inhaled oxygen diffuses into the bloodstream and encounters the hemoglobin protein. Oxygen then binds to each heme group, resulting in 4 oxygen molecules to 1 hemoglobin protein. Once oxygen is bound to hemoglobin, it's renamed to oxyhemoglobin. Red blood cells transport the oxyhemoglobin throughout the body to tissues that require oxygen. Oxygen then leaves heme groups when hemoglobin is exposed to blood that is somewhat acidic. Blood becomes acidic when there is high concentrations of carbon dioxide in the blood. Gaseous carbon dioxide reacts with water, forming carbonic acid, and makes the blood slightly acidic. High concentrations of carbon dioxide in blood is due to increased metabolism, such as exercise or stress. The more carbon dioxide you generate, the more oxygen gets released into the blood. The system works perfectly, until carbon monoxide is present. Then things go horribly wrong. The degree of how strong or weak 2 molecules bind is called affinity. Oxygen's affinity for hemoglobin is measured in millimeters of mercury and is about 27 units. This is a fairly weak affinity, but intentionally, because oxygen has to be able to leave hemoglobin at a moment's notice. Carbon monoxide's affinity for hemoglobin is much higher, at 65 millimeters of mercury, or 240 times stronger than oxygen. This stronger affinity keeps carbon monoxide bound to hemoglobin much more tightly than oxygen, and it doesn't let go for about 5 hours. Carbon monoxide's first effect on the body is when it binds to a heme group on hemoglobin. Once bounded, it takes the place of an oxygen molecule, allowing only 3 oxygen to bind instead of 4. It should also be noted, when carbon monoxide binds to hemoglobin, hemoglobin is renamed to carboxyhemoglobin, due to its different properties. One notable property is that the molecule itself produces a bright cherry red color, which is a telltale sign of carbon monoxide poisoning. One who has inhaled a significant amount of carbon monoxide will have a cherry red hue to their skin. This is because a large amount of hemoglobin in their blood has been converted to carboxyhemoglobin. Unfortunately, by the time the skin has identifiable color, the victim is usually deceased, due to the high concentrations in the blood. Taking the place of oxygen on hemoglobin isn't the only thing carbon monoxide does. It also affects the other oxygen indirectly as well. The charge on carbon monoxide stabilizes the iron ion in the center of the protein. When iron becomes stabilized, it changes the physical shape of the heme groups. As a result, the oxygen molecules stay fixed to the heme groups as long as carbon monoxide is also present. In essence, oxygen cannot be used by the body. As a result, the oxygen cannot be released into the blood, causing asphyxiation or deprivation of oxygen. Early symptoms of asphyxiation first manifest as flu-like symptoms, such as headache, weakness, and dizziness. As more carbon monoxide is inhaled, symptoms progress to chest pain, vomiting, confusion, irregular heartbeat, and loss of consciousness. Once unconsciousness is reached, all that's left is for the brain to shut down, and then it's over. Depending on the concentration of carbon monoxide, fatal effects may happen within minutes or hours. The low end of fatal concentrations begin at 3,200 parts per million and can cause death within 30 minutes. At 12,800 parts per million, fatal effects can occur within 3 minutes or less. In contrast, lethal concentrations of carbon dioxide is about 40,000 parts per million because carbon dioxide is not toxic. There just has to be enough to displace available oxygen, whereas carbon monoxide directly shuts down oxygen distribution. Carbon monoxide is also less dense than oxygen and carbon dioxide, meaning it will diffuse throughout a room fairly well, instead of settling near the ground. We know how carbon monoxide poisoning works, but where does it come from? Carbon monoxide is produced when there's a low amount of oxygen during a combustion reaction. In combustion reactions, hydrocarbons are burned in the presence of oxygen, resulting in the formation of water and carbon dioxide. If there's not enough oxygen present, there won't be enough to make carbon dioxide. Instead, the reaction will still proceed, but only one oxygen will bind to carbon instead of two, making water and carbon monoxide. Low oxygen combustion reactions typically occur when something is burning in a closed space, where there is a low amount of oxygen available. The most common occurrence of this is an internal combustion engine being run in a closed space, such as a garage. Carbon monoxide can also occur in your own home, when furnace ventilation gets blocked, which is a common occurrence in the winter. Charcoal is also known to release significant amounts of carbon monoxide during its combustion, and was famously used as a means of by K-pop singer Chung Young. There is another occurrence of carbon monoxide poisoning in everyday life that millions of people partake in: smoking. Inhaling smoke from both burning tobacco and cannabis delivers carbon monoxide directly into the blood. Whether it's rolled in paper or in a pipe, the combustion does not burn with sufficient oxygen, and therefore produces carbon monoxide. There is enough carbon monoxide in cigarette and cannabis smoke to develop mild carbon monoxide poisoning, depending on how much is smoked per day. In a study from the Spanish Clinical Journal, 228 smokers were tested for carbon monoxide presence in their blood. The average non-smoker has a 1% carbon monoxide concentration in their blood, from biological production and small concentrations in the air. In contrast, smokers who had between 1 and 10 cigarettes per day had a blood carbon monoxide concentration of 5.2%. Those who smoked more than 20 cigarettes per day had a 9.6% concentration. Blood levels of 10% or higher is defined as carbon monoxide poisoning. Symptoms that chronic smokers have, such as fatigue, headache, shortness of breath, and confusion, are more likely than not the effects of mild carbon monoxide poisoning. In fact, chronic smokers have more hemoglobin in their blood than a non-smoker, as their body has to make more to compensate for hemoglobin that's been inactivated. Despite how dangerous carbon monoxide poisoning is, if caught quickly, it can be treated. Patients are given oxygen through breathing masks, or if necessary placed in hyperbaric oxygen chambers, where they breathe nearly pure oxygen. High concentrations of oxygen cause carbon monoxide to unbind from the heme groups much faster, reducing the time it's attached from 5 hours to about an hour and a half. With carbon monoxide unbound, oxygen can bind and unbind from hemoglobin as normal. Sometimes science can be seen as difficult, foreign, and even boring. Yet, there are times when science grabs our attention and draws us in, yearning for more answers. Often, what draws us in are topics that are dark, macabre, or terrifying. It's with the intention of this video that you too were drawn in and sought to have your questions answered. Thanks for watching Dark Science.